Hello everyone, let's now study about other forms of wave equation. These are useful to solve numericals. To understand this, let's recall the basic form of wave equation. It says y, which is a function of x into t, this is equal to a into sine omega t minus k into x plus phi. To make it more simple, let's take phi, which is called as initial phase as 0. Then y is equal to a into sine omega t minus k into x. This is what we get, where it is implied that y is a function of x and then t. It's not written next to y separately, but it is implicit, it is understood. Now if you write k in terms of lambda, we know that k is equal to 2 pi by lambda. Putting it here, we get y is equal to a sine of omega t minus k becomes 2 pi by lambda into x. So this is one form of a equation. Now from here, suppose from here we rewrite this, that is y is equal to a into sine into omega is equal to 2 into pi into f into t minus 2 pi by lambda into x. From here, if we pull out 2 pi outside, that is 2 pi which is common from here, if you pull it outside, then what we get would be y is equal to a into sine into 2 pi into ft minus x by lambda. So this is other form of the wave equation. Now we can write it further also. We know that frequency is 1 by time period. So therefore y is equal to a into sine, the third form of it, sine into 2 pi into t by capital T minus x by lambda. So this is other form of the wave equation. And write the fourth form. We shall look at the first form itself. From first form, from here, if you pull k outside, so y is equal to a into sine into, if we pull k outside, then what remains here would be this omega by k into t minus x. But recall what was v. V was omega by k. Therefore y is equal to a into sine of k into vt minus x. So this is other form of the wave equation. Similarly, you can write in many forms also, but these four are the most basic forms of the wave equation. So remember this to solve numericals. In the previous case, we got certain forms of the wave equation. Now those wave equations were true when the wave was assumed to move along the positive x direction. Recall that the whole equation is for a one-dimensional wave, which means the energy moves along only one dimension. Now instead of assuming that the wave is moving along the x direction, imagine that if the wave moves along the negative x direction. In that case, if you look at the expression for t, we wrote t as t minus x by v. In that case, it becomes t plus x by v, or in more simple language, we can replace x with minus x. Then the equations would take the form given here. So we add y is equal to a into sine omega t minus 2 pi by lambda into x. Here, since the wave moves on the plus x direction, minus x direction, this term becomes here plus. Similarly, we get other forms also. So we get plus everywhere. So these are the equations for a wave moving along the negative x direction.